we're going to learn about our last method to solve systems of equations here. We're going to look at the elimination method. So we're going to eliminate one of the variables based on adding the two equations or subtracting the two equations together. Mainly, we're just going to look at adding. So let's look at our first equation here, or our first system of equations. So still two variables, two equations. We have negative 4x minus 2y is equal to negative 12, and 4x plus 8y is equal to negative 24. So what we're going to look here, you'll notice that I have a negative 4x and a positive 4x. So both of these are in standard form. So before, with our graphing, we had two equations that were both solved for y. With substitution, one of our variables was solved for, and then now we have both equations are in standard form. So this right here, we're going to look at, we have a negative 4x and a positive 4x. So if I were to go through and I were to add these two equations here, just like you did way back, like when you first started adding, so like top plus bottom. So what I'm going to do is I'm going to add negative 4x plus 4x. That's going to make 0. That's what makes it eliminated. So this gets eliminated because when I add the two equations together, negative 4x plus 4x makes 0. So then I have negative 2y plus 8y, which is going to make it 6y. And then I have negative 12 plus negative 24 is going to make a negative 36 there. So now, I just add, all I did was add the two equations together. Now I will go through and solve. Divide each side by 6, and y is equal to negative 6. Now, we have one variable, and just like the rest of the time, we're going to have to go back and plug that in and solve for x on the other, any equation. It doesn't matter which equation you want to pick. So I'm going to pick this equation right here because I have lots of positives, so that's what I like to stay with. It does not matter. So I have 4x plus 8 times negative 6. So what I did is I took negative 6 and I replaced it in for y right there. Then I'm going to that's going to be equal to negative 24. And then I will simplify. So this is 4x, and this makes a negative 48 is equal to negative 24. So I'll add 48 to each side. And so 4x is going to be equal to 24. Divide each by 4, and x is equal to 6. So remember that our equation here, we will have an x and a y. So we write that as an ordered pair because remember that's where the two lines are going to cross. If I were to graph both of those two lines, they're going to cross at 6, negative 6. That is our solution. Now, sometimes just pay close attention. It will ask for either just the y variable or just the x variable, and then you just solve for one of those. Second example here, we have negative x plus 7y is equal to 72, and then 10x minus 7y is equal to negative 18. So what you're looking for here to be able to eliminate, you want the same coefficient in front of your variable there. So like I have both 7s in front of my y variable, so this time that's what I'm going to eliminate. So it's not necessarily you're always going to eliminate one of the two variables, like every single time it's going to be x or every single time it's going to be y. You want to look and see which one has the same coefficient. So notice that in front of y, both have 7. One's a positive, one's a negative. That's another thing you want to look for. Same coefficient, opposite signs. So what will happen is I'm going to add these two equations together. So I have negative x plus 10x is going to make 9x. And then I'm going to have, this makes 0 is equal to 54, so 72 plus negative 18 is 54. Then I'll divide both sides by 9, and x would be equal to 6. Again, lots of 6's. Now I'm going to go back and replace this into any equation I would like. I don't know that either one of these is one I would necessarily say, oh yeah, I'm really happy about plugging it in here. I'm going to go with plugging it into this x here. So I have 10 times 6 minus 7y is equal to negative 18. So this makes 60 minus 7y is equal to negative 18. And then I'm going to subtract 60 from each side. So that makes negative 7y is equal to negative 78. And then I'll divide this by negative 7. This turns out to be kind of ugly. Looks like 78 over 7. So y is 78 over 7. So then final answer, x is 6 and y is 78 divided by 7. I think something went kind of crazy wrong there, but we're just rolling with it, rocking with it. Okay, and now let's look at our last example here. So remember what I'm going to do for elimination. I'm going to look for the same coefficient, opposite signs. So you'll notice that the coefficient in front of y is the same on each of those, and one's negative and one is positive. So I'm going to eliminate my y this time. So I'm going to have 12x plus 40x is going to be 52x. That makes 0, so that gets eliminated, subtract out. And then I have 24 plus negative 76. So I get a negative 52. So then I'll divide each side by 52 that's in front of x. And so x is equal to a negative 1. Now I'm going to take that, plug it back in. This time I'm going to choose the top equation just because I haven't done that yet. So I'll plug in negative 1 for x here. So I have 12 times negative 1 minus 12y is equal to 24. So this makes negative 12 minus 12y equals 24. I'll add 12 to both sides. And so negative 12y is equal to 36. Divide by negative 12, and y is equal to negative 3. So now, final solution. Remember, you like to write it as an ordered pair. Negative 1, negative 3. That would be where those two graphs cross. Remember, that's that solution for systems of equations. So just a couple of things that I kind of want you to just remember. You're looking for the same coefficient, which is the number in front of a variable, okay, with opposite signs. So you want one to be positive and one to be negative. So same coefficient, same number in front of the variable, but then opposite signs. That's what helps you eliminate that variable, and then you add the two, so that you're going to eliminate variable, and then you're going to add the two equations together. Once you do that, you'll solve, and then you'll plug in and solve again. So you'll plug in and solve again one more time. All right, so this is just the beginning steps of elimination. There will be a part 2 coming to you because not always is that coefficient going to be the same. We're going to make it the same. That's on the next lesson.